Okay, so question number 18. I realized that I did not give this information to you in your final review, but I want to give it to you right now. So 1 mile is 5,280 feet. You will not be asked a question where you would have to convert on your final exam. It's just the way that this question was worded. So anyways, we have an airplane flying 4,000 feet above the ground. We get an angle of depression, and what is the horizontal distance? Okay, all this sounds great. First thing I want to do though is convert this feet to miles so that my final answer is my final answer. I don't have to worry about converting at the end. So I'm going to do this work up here. 1 mile, 5,280 feet. So I want to know how many miles, x miles, is 4,000 feet. This is the way I like to do it. It's just the way that I'm comfortable with. You can use dimensional analysis, but I like setting up the proportion. It's easier for me to think about it that way. Cross multiply, I get 4,000 is equal to 5,280x, and I'm going to divide by 4,000 by 5,280, and this is what I get. I get 0.75 repeated. So I'm going to just change that to a fraction, and that way it'll just be a little bit easier for me to deal with. So 25 over 33 is equal to x, and that's in miles. All right. You could convert at the end. You'd get the same answer. So just whatever you kind of feel like. 25 over 33 miles. Here's my plane. Now, they talk about the angle of depression. So when we learned about angle of depression, I told you guys that the angle of depression is always measured from the horizontal. This right here is the angle of depression, this 5.4, measured from that horizontal path. So that's a really kind of key thing that you have to know to draw this picture. This is where the 5.4 is not right in here. What we've created is a right triangle. They're asking, what is the horizontal distance? This right here is the horizontal distance. This diagonal piece is like the regular distance, but this h is the horizontal. So they're asking, what's h? Right triangle. There's a couple of ways that we can do this. First off, they're a little like geometry fact from like 10th grade geometry. Alternate interior angles. If this angle is 5.4, then this angle is 5.4, alternate interiors. The other part of it too is that this is a 90-degree angle. So you could always do 90 minus 5.4 and get 84.6. It doesn't matter. It'll all work out the same. 84.6 and 5.4 and 90 gives you 180. So it doesn't matter. It doesn't matter which one you use. We don't have the hypotenuse here, so we're limited to using tangent. There's no reason to find the hypotenuse, so don't do it. So tangent, and I'm going to use tangent of 84.6. 84.6 is equal to h over 25 over 33. All right, so I'm going to multiply both sides by 25 over 33 times 25 over 33. So I'm going to get 25 tangent of 84.6 divided by 33. You'll get about 8.01 miles, and they want the nearest tenth of a mile. So h is just going to be 8.0 miles. Now, if you find this in feet first, you'll get like 42,000 feet. You'll actually get a large amount of feet. Make sure you change that to miles. Okay, I'm not going to do 19 or 20. I just want to remind you guys how to do this. Secant doesn't exist in your calculator. You have to do 1 over the cosine of 126.2. All right, does not exist. And then when you're finding inverse, this method is true method for cosecant, secant, and cotangent, all those inverses, or all these reciprocal identities. When you're finding the inverse, what you have to do is you find whatever that reciprocal is, so cotangent goes with tangent, and then you do 1 over the number they give you, okay? And then that's what you take the inverse of. So just be careful when we do these problems. They're meant to be easy problems because they're calculators, so just make sure that you know how to do that skill. This is in chapter 2. All right, number 21 is arc length. So just as a reminder, it's been a while. That's our arc length formula. Theta is always in radians. You will have to know this. And then area of a sector is 1/2 theta r squared. Once again, theta is in radians. R is the radius. S is arc length. And then A, area. Okay, you guys can do 21 though. All right, in triangle ABC, I'm not going to do this problem. I'll set it up for you guys, and then you guys can go from there. In triangle ABC, A is 30, B is 70, A is 80. Find the length of side C. All right, so ABC. There's nothing here to suggest that this is a right triangle. 30, 70, and A is 8. All right, so if you're going to find the length of side C, what I would do is I would find angle C first. Angle C, 7 and 30. Angle C would have to be 80 degrees. So then I have a pair. I have that A pair, and then I can use law of sines to find side C. I don't have to worry about the ambiguous case here because you're finding a side, not an angle. And then you have a couple of options. I like to use, so if you find C, so when you find C, if you find side C, then you could do 1/2 AC sine B for your area of a triangle. Couple of options for 22. Do what you like, do what you feel is right. You will be given your area of a triangle formulas, so don't worry about that. I will not give you law of sines. But for 22, I would use law of sines. We don't have to worry about the ambiguous case.